myelinate your postural circuitry. A practical but scientific explanation why chiropractic care takes time. Tiny movement is responsible for building skills both in sports and your activities of daily living. Tiny movement is built on this revolutionary scientific discovery involving a neural insulator called Myelin, which some neurologists now consider to be the Holy Grail of acquiring skill. And here's why. Every human skill, whether it's improving posture, maintaining spinal alignment, playing baseball, or playing back, it's created by a chain of nerve fibers carrying a tiny electrical impulse, basically a signal traveling through a circuit, and it's propagated to your brain through your spinal cord and sensed by your brain through tiny sensors located in your joints, especially your spinal joints, in which the movement of your spine acts like a windmill or the power generator to your brain, as described by a Nobel Prize winning scientist. So myelin's vital role is to wrap those nerve fibers the same way that rubber insulation wraps a copper wire, making a signal stronger and faster by preventing the electrical impulses from leaking out. You know, in the book, The Talent Code by Daniel Coyle, we learn that when we fire our circuits in the right way, when we walk with the right posture, when we maintain our spinal motion and alignment, or practice swinging that bat or playing that musical note, our myelin responds by wrapping layers of insulation around that neural circuit. And each new layer adds a bit more skill and speed. And the thicker the myelin gets, the better it insulates, and the faster and the more accurate our movements and even our thoughts become. So myelin is important for several reasons. It's universal. Everyone can grow it, mostly swiftly during childhood, but also throughout life. Again, this is one reason pediatric chiropractic checkups from infants to adolescents is very important. Another reason, it's done with random, repetitive, tiny movements. Its growth enables all manner of skill, mental and physical, and it's impossible to perceive. We can't see it, you can't feel it, and we can't sense its increase only by its magical seemingly effects. So our baby starts to be more aware, interested in crawling, to walking, to running, to riding a bike, and on and on. So most of all, myelin is important because it provides us with a vivid new model for understanding. And as Daniel Coyle puts it, skill. Skill is a cellular insulation that wraps neural circuits and that grows in response to certain signals. Biomechanist Katie Bowman would add that the textures you choose to walk on turn on different signals as sensed by the receptors in the joints while they glide over that texture. So if you have a dysfunctional joint, the result would be a dampening effect of that neural circuitry, understand? So maintenance of your joint health ensures proper response to these signals. You see, the more time and energy you put into the right kind of practice, whether it's shooting the free throw shot, or to standing upright, to proper ergonomics when you're sitting, to proper spinal alignment, the longer you stay in the tiny movement zone, firing the right signals through your circuits, the more skill you get. Or to put it a slightly different way, the more myelin you earn. So all postural changes, skill acquisitions, and therefore all talent hotbeds operate on the same principles of action, no matter how different they may appear to us. As Dr. George Bartzokis, a UCLA neurologist and myelin expert, right? He put it this way. He says, all skills, all language, all music, all movements are made of living circuits, and all circuits grow according to certain rules. See, the idea that all brain circuitry grow by the same cellular mechanism seems strange and surprising because the skills are so dazzlingly varied. But then again, all of this planet's variety is built from shared adaptive mechanisms. Evolution could have it no other way. We are animated Earth. Redwoods differ from roses, but both grow through photosynthesis. Elephants differ from amoebas, but both use the same cellular mechanism to convert food into energy. Tennis players, singers, and painters don't seem to have much in common, but they all get better by gradually improving timing and speed and accuracy, by honing neural circuitry, by obeying the rules of nature inherent to us from our ancestors. I call our inner aborigine. In short, by growing more myelin. So chiropractic adjustments build on each other, similar to the demand of weight training to build new circuits for muscle strength, endurance, and even more muscle. They both require deep practice and repetition. You know, Dr. Dean Ornish said, in just 3 months, you change hundreds of genes simply by changing what you eat and how you live. So deep practice is built on a paradox. Struggling in certain targeted ways, operating at the edges of your ability where you make mistakes. Actually, mistakes makes you smarter. Or to put it a slightly different way, experiences where you're forced to slow down and make errors and correct them, as you would if you were waking up and, walking up an ice-covered hill, slipping and stumbling as you go. You end up making that swift and graceful movement without realizing it. This is why a small child takes nearly 3,000 steps and falls 75 times an hour while learning to walk. Another obvious reason for pediatric chiropractic, that sudden jerks turn on that proprioception, part of that windmill sensor Nobel Prize recipients have pointed out during the normal movement of your spine. So Robert Bjork, the chair of psychology at UCLA, he spent most of his life delving into questions of memory and learning. And he says, we think of effortless performance as desirable, but it's really a terrible way to learn. And he adds this, he says, things that appear to be obstacles turn out to be desirable in the long haul. One real encounter, even for a few seconds, is far more useful than several hundred observations. So researchers at Washington University of St. Louis can help clarify what we're talking about here. Students were divided into 2 groups to study a natural history test. And Group A studied the paper for 4 sessions. Group B studied for only 1, but was tested 3 times a week. A week later, both groups were tested, and Group B scored 50% higher than Group A. They'd studied 1/4 as much, yet learned far more. See, if you applied these ideas to your schoolwork, you might raise your GPA by a full point while studying half as much. That's what many students report when you use tiny movement. See, the reason Robert Bjork explained, it resides in the way our brains are built. We tend to think of our memory as a tape recorder, but that's wrong, he says. It's a living structure, a scaffold of nearly infinite size. And the more we generate impulses from tiny movement, encountering and overcoming difficulties especially, the more scaffolding we build. The more scaffolding we build, the faster we learn. Not just for school, but for the brain power it takes to keep our bodies healthy. That scaffolding that's produced is with tiny movement. And best of all, without taking a single pill or a drug. The blame it, name it, tame it with a drug approach, the pill for an ill. You see, I want to take you away from pain management into true health management. And the vast majority of you watching this got duped into believing you just need the right medication, the right drug, the right pill, or even a nutraceutical formula, when the true formula has always been built in your DNA. And that, my friend, is tiny movement. So daily repetitive tiny movement, especially that movement of your spine, your backbone to health, needs installing natural bandwidth. See, Myelin is the key to talking, to reading, to learning skills, movement, being human. And most people, including doctors, are under the impression that, the key to learning skills and being human resides in our brain's neurons. that flickering web of interconnected nerve fibers and, the famous synapses or connections through which they link and communicate. But the latest research proves it's much more than that. And while we still consider neurons and synapses to be vitally important, but the traditional neuron-centric worldview is being fundamentally altered by a huge scientific breakthrough in science right now, the human brain revolution. And this humble-looking insulation, myelin, it turns out, plays a key role in the way our brains function, particularly when it comes to acquiring new skills. So the revolution is built on 3 simple facts. Let me cover those. Number 1, every human movement, especially the tiny movement, even our thought or feeling, is a precisely timed electric signal traveling through a chain of neurons, a circuit of nerve fibers. Number 2, myelin is the insulation that wraps these nerve fibers and increases the signal strength, speed, and accuracy. And number 3, the more we fire a particular circuit, the more myelin optimizes that circuit, and the stronger, faster, and more fluent our movements and our thoughts become. So everything neurons do, they do pretty quickly. It happens with the flick of a switch. But flicking switches on or off is not how we learn a lot of things. Improving posture and spinal alignment and spinal motion, strength training, or playing a piano or chess or baseball takes a lot of time, and that's what myelin is good at. See, repetition builds skill and neural networks. Hab's law tells us that neurons that fire together wire together. So the input is all that stuff that happens before we perform an action. Seeing the ball, feeling the racket's position in our hand, deciding to swing. The output is the performance itself, the signals that move the muscles with the right timing and force to take a step, turn the hips, the shoulders, the arm, and on and on. So when you hit that backhand or play an A minor chord or make a chess move, an impulse travels down those fibers through voltage through the spinal cord, triggering the other fibers to fire. So this truth isn't just in the musculoskeletal system. It's all the systems in the body, from your DNA to your cells, even the health of your microbiome. The point is that these circuits, not our obedient, mindless muscles, are the true control center of every human movement, thought, and skill. Many neurologists, they would tell you that in a profound way, the circuit is the movement. It dictates the precise strength and timing of each muscle contraction, the shape and the content of each thought. So a sluggish, unreliable circuit means a sluggish, unreliable movement. Stiffness. On the other hand, a fast, synchronous circuit means a fast, synchronous movement. Flexibility. Again, I'm not just talking about contracting a bicep muscle. Even your genetic expression is involved. Your cellular biology is involved. Your tissue health, your hormones, even your organ health are dictated by the neural circuitry in your brain from tiny movement. Of course, when a coach uses the phrase muscle memory, he or she's actually talking about circuits. By themselves, our muscles are as useful as a puppet without strings. You heard the expression, our skills are in our wires. The more we develop a skill circuit to develop better posture and spinal alignment or athleticism, the less we're aware that we're using it. So we're built to make skills automatic, to stash them in our unconscious mind. And this process, which is called automaticity, right? It exists for this powerful evolutionary reason. The more processing we can do in our unconscious minds, the better our chances of noticing that saber-toothed tiger lurking in the brush. It also creates this powerfully convincing illusion. A skill, once gained, feels utterly natural, as if it's something we've always possessed. That's the sweet spot. See, these two insights, skills as brain circuits and automatic, creates a paradoxical combination. We're forever building vast, intricate circuits, and we're simultaneously forgetting that we built them, which is where myelin comes in. Daniel Coyle, he says, to say that Myelin looks boring is to flatter it. Myelin does not look merely boring. It looks fantastically, unrelentingly, stupendously dull. So if the brain is a Blade Runner cityscape of dazzling neuronal structures, flashing lights and whizzing impulses, then Myelin plays the humble role of the asphalt. It's the uniform, seemingly inert infrastructure. It's composed of a dull substance known as a phospholipid membrane, a dense fat that wraps like electrical tape around a nerve fiber, preventing the electrical impulses from leaking out. It arrives in a series of long, rounded shapes that more than one neurologist unpoetically describes as sausagey. So given the seamlessly obvious supremacy of neurons, the first brain researchers confidently named their new science neurology, even though myelin and its supporter cells, known as white matter, account for more than half of the brain's mass. You know, for a century, researchers have focused their attention on neurons and synapses rather than on their seemingly inert insulation, which they studied mostly in relation to multiple sclerosis and other myelin-destroying autoimmune diseases. And again, the major focus in conventional research is and has always been pathological-based focused, not on how to get and stay well, or healthology. That term is not yet in the dictionary or the study of health. But just as Martin Seligman, who shifted psychology, and the 99% of psychology research back at the time focused on neurosis, he shifted it to focus away from that into positive psychology, which focuses not on sickness and pathology, but on the promotion of health. So there's hope here. And as it turns out, researchers were mostly correct. The neurons in the synapses can indeed explain almost every class of mental phenomena: memory, emotion, muscle control, sensory, perception, and so on. But there's a key question that neurons can't explain. Why does it take people so long to learn complex skills? And one of the first clues to Myelin's role was uncovered in the mid-1980s. It was an experiment involving rats in a toy dump truck, right? Bill Greeno, University of Illinois, he raised 3 groups of rats in varying ways. In group 1, the individual rats were isolated from the other rats, and each one in a large plastic shoebox. The rats in the second group were raised with other rats, but also in shoeboxes. The rats in the third group, however, were raised in an enriched environment, surrounded by other rats and a pile of toys that they instinctively played with, even to the point of figuring out how to work the lever on the dump truck. So when Greeno autopsied the animals' brains after 2 months, he found that the number of synapses in the enriched environment group had increased by 25% compared with the other 2 groups. So Greeno's work was well received, helping establish the idea of brain plasticity, and in particular, the notion that the brain has critical developmental windows during which its growth responds to its environment. But buried in Greeno's study was a secondary finding that was largely ignored by the scientific community. Go figure. Something else had also grown by 25% in the enriched environmental group. It was white matter, specifically myelin. He later said, "We've been ignoring myelin. Everybody thought it was a bystander. But then it became clear that big things were happening there." You know, it's just an interesting nerdy insight here. Epigenetics was actually discovered around the same time that Watson and Crick discovered DNA, back in the 1960s. And of course, we speak of epigenetics, meaning above, but think of it as the environment washing over your genes. Anyway, epigenetics was ignored by scientists, and the cliche phrase was born: it's genetic. And today, when that phrase is still used by doctors even, right? And just understand that, is their arrogant-minded way of saying, I don't know. Again, the question of genes or environment is not open for debate in the scientific community. It's environment. It always was. So just like we thought the earth was flat and it's not, or it's genetic and it's not, we've arrived at a new frontier in brain health, myelin. In fact, neurons and synapses continued to get the lion's share of research attention until around the year 2000, when a powerful new technology called diffusion tensor imaging that allowed neurologists to measure and map myelin inside living subjects. And suddenly researchers began to link structural deficiencies in myelin to a variety of disorders, including things like dyslexia, autism, attention deficit disorder, post-traumatic stress syndrome, and even pathological stuff. And lying. You know anybody who lies all the time? While many researchers focus on myelin's link to disease, like the positive psychology shift toward the promotion of health, another group became interested in a role not associated with pathology at all. Yay. They wanted to learn how it might play in normal, even high-functioning, healthy individuals. And that was the group that I was interested in as a chiropractor who's focused on health promotion, how to get and stay well for a lifetime. So more studies followed. In 2005, Frederick Olin, he scanned the brains of a concert pianist and found a directly proportional relationship between hours of practice and white matter. In 2000, Torkel Klingelberg linked reading skill to white matter increases. 2006, Hazel Pujo did the same for vocabulary development. 2005, the Cincinnati Children's Hospital study of 47 normal children aged 5 to 18 correlated increases IQ with increased organization and density of white matter. Other researchers like Dr. Fields, well, he uncovered the mechanism by which these myelin things increased, how they happened. And as he described in a 2006 paper in the journal Neuron, supporter cells called oligodendrocytes and astrocytes, well, they sense the nerve firing and respond by wrapping more myelin in the fibers that fire. The more the nerve fires, the more myelin wraps around it, understand? So the more myelin that wraps around it, the faster the signals travel, increasing velocities up to 100 times over signals sent through an uninsulated fiber they found. So the studies are piling up, gradually coalescing into a new picture in health. Myelin is an infrastructure, all right, but with a powerful twist. Within the vast metropolis of the brain, myelin quietly transforms narrow alleys into broad, lightning-fast superhighways. Neural traffic that once trundled along at 2 miles an hour can, with myelin's help, accelerate to 200 miles an hour. So the refractory time, the wait required between one signal and the next, decreases by a factor of 30. That increased speed and decreased refractory time combine to boost overall information processing capability by, get this, 3,000 times broadband indeed. And what's more, myelin has the capacity to regulate velocity, speeding, or occasionally even slowing signals so they hit synapses at the optimal timing. Timing is vital because neurons are binary. Either they fire or they don't. No gray area here. So as chiropractors, we've understood this importance since the inception of chiropractic back in 1895. Not the science of it, but the tiny movement part. See, whether they fire depends solely on whether the incoming impulse is big enough to exceed their threshold of activation. Again, subluxation or dysfunctional joints, without question, impact this. To explain the implications, imagine a skill circuit where two neurons have to combine their impulse to make a third high threshold neuron fire. So let me give you an example, a golf swing, right? But here's the catch. In order to combine properly, those two incoming impulses, they must arrive at nearly exactly the same time. Sort of like two small people running at a heavy door to push it open, right? That required time window turns out to be about 4 milliseconds, or about half the time it takes a bee to flap its wing just once. So if the first two signals arrive more than 4 milliseconds apart, the door stays shut. The crucial third neuron doesn't fire, and the golf ball soars into the rough. So your brain has so many connections and possibilities that your genes can't code the neurons to time things so precisely. But through the proper tiny movement and exercise, you can build myelin to do it. While the premise, the precise mechanism of optimization does remain a mystery for now, but researchers theorize that a feedback loop similar to an old chiropractic concept we call the safety pin cycle. Anyway, this loop is at work. It's monitoring, it's comparing, and it's integrating outputs. And the overall picture adds up to a process elegant enough to please Darwin himself. Nerve firings grow myelin, and myelin controls the nerve impulse speed, and the nerve impulse speed grows brain circuitry. Myelin doesn't make synapses unimportant. To the contrary, most neurologists will tell you that synaptical changes, these connections, remain the key to learning. But myelin plays a massive role in how that learning is manifesting itself. In other words, signals have to travel at the right speed, arrive at the right time. And myelination is the brain's way of controlling that speed. Again, I love Nobel Prize winner Dr. Roger Sperry's model of the windmill, because it takes the right wind intensity to move the windmill with the right directional currents to transform the wind energy into electricity. Tiny movement, moving 3 minutes every 30 minutes while maintaining a highly functioning and mobile spine, is the biological windmill that might very well be the mechanism that most experts have dropped the ball on and don't understand. And another reason we have doctors of chiropractic primarily handling the maintenance of spinal care. At any rate, myelin theory, as seen through the eyes of researchers, is impressive, as you can see. And chiropractic science gives us a glimpse into a deep practicing brain fueled by proper tiny daily movement. When a nerve fiber fires, the oligodendrocyte senses it, grabs hold, and starts wrapping. Under the microscope, it looks like a glowing green squid-like creature, and each tentacle curls and extends as the oligo squeezes cytoplasm out of itself until only a cellophane-like sheet of myelin remains. And that myelin, still attached to the oligo, proceeds to wrap over and over the nerve fiber with unworldly precision, spiraling down on each end to create the distinctive sausage shape, tightening itself like a threaded nut along the fiber. So, in a nutshell, each time we deeply practice proper posture, maintain our spinal alignment and spinal motion, to a 9-iron swing or a guitar chord, or a chess opening, we're slowly installing broadband in our circuitry. We are firing a signal that those tiny green tentacles sense. They react by reaching toward the nerve fibers. They grasp, they squish, and they make another wrap, thickening the sheath. They build a little more insulation along the wire, which adds a bit more bandwidth and precision to the brain circuits, which translates into a bit more skill and speed. Struggle is not optional, it's neurologically required. In order to get your skill circuit to fire optimally, you must by definition fire the circuit sub-optimally. You gotta make mistakes and fall down. You gotta pay attention to those mistakes. You must slowly teach your circuit. You must also keep firing that circuit by practicing, if you're an athlete, tiny movement all day long in order to keep the myelin functioning and wrapping. After all, myelin is living tissue. This is true for the growth and the development of your child, for their brain, as well as maintaining good spinal hygiene, for your posture and spinal alignment, as it is also true to improve athletic performance, to musical performance, to language, to speech, to vocabulary, right down to your DNA. Without tiny movement, your DNA suffers. So let me sum this up. It's time to rewrite the maxim that practice makes perfect. The truth is, practice makes myelin, and myelin makes perfect. And myelin operates by a few fundamental principles. Number one, the firing of the circuit is paramount. Tiny movement fires the circuit so long the mechanism isn't decaying or rusty. Myelin is not built to respond to fond wishes or vague ideas or transformation that washes over us like a warm bath. The mechanism is built to respond to actions, the literal electrical impulses traveling down the nerve fibers through the cord, especially those nerve sensors firing along our spinal joints during the normal movement of our spine, where those receptors called proprioceptors, body positioning sensors, and mechanoreceptors, movement sensors, they're more numerous than any other part of your body loaded in your spine. It responds to the urgent repetition, and there are evolutionary reasons for this. The reason we need 8 to 10 miles of movement every day. I won't get into that here. For now, we'll simply note that deep practice is assisted by the attainment of a primal state, one where we are attentive, hungry, focused, even desperate. Number 2, myelin is universal. One size fits all skills. Our myelin doesn't know whether it's being used for playing shortstop or playing music. Regardless of its use, it grows according to the same rules. In other words, dynamic movements are the key. Variation in your movement, like dancing, where you move your hips, your backbone, and your neck in very different ways. Myelin is its own government. Circuits that fire it get insulated. The movement of your spine is loaded with the most movement sensors. Again, those mechanoreceptors and those proprioceptors that fire these circuits and creates more myelin. If you move to Mexico, your island, it would wrap fibers that help you say Spanish verbs. To put it another way, myelin doesn't care who you are. It cares what you do. This is true for movement as well as it is for your mind for speech or vocabulary, as I discussed earlier. Think of your kids with those issues. See, myelin wraps, it doesn't unwrap. Like a highway paving machine, myelination happens in just one direction. And once a skill circuit is insulated, you can't uninsulate it except through age, immobility, or disease. That's why habits are hard to break. The only way to change them is to build new habits by repeating new behaviors, by myelinating new circuits. Again, stick with NASA's tiny movement rule of moving. 30 minutes, every 3 minutes, you move. And your golden years will truly be golden. You will achieve tiny movement ageless health. I've got a video on that. Check that one out. So age does matter, right? In children, myelin arrives in a series of ways. Some of them are determined by the genes, some depending upon activity. So these waves last into our 30s, creating these critical periods during which time the brain is extraordinarily receptive to learning new skills. Thereafter, we continue to experience a net gain of myelin until around the age of 50, when the balance tips towards the loss. So we retain the ability to myelinate throughout life, thankfully. And it was 5% of our illegals remain immature, always ready to answer the call. But anyone who has tried to learn a language or a musical instrument later in life can testify that it takes a lot more time and sweat to build the required circuitry. And this is why the vast majority of world-class experts stay young, in my opinion. Their genes don't change as they grow older, but their ability to build myelin does. On one level, the study of myelin sounds like an exotic new neuroscience, right? But on a totally different level, myelin is similar to another evolution-built mechanism that you use every day. That's your muscles. If you use your muscles a certain way, by trying hard to lift things you can barely lift, those muscles will respond by getting stronger. If you fire your skill circuits the right way, by trying hard to do things you can barely do, that deep practice, then your skill circuits will respond by getting faster and more fluent. And it goes in the opposite direction. Again, researchers from NASA discovered that after just 30 minutes of immobility, like sitting, causes gray matter lesions to the brain, shrinkage of the prefrontal cortex, and a pre-diabetic state. And during the same study, 5 hours of immobility causes the white matter lesions. Again, these were on brain scans, but we know myelin comes from white matter. So the speed of the nerve signals are dampened. And Of course, we know that the white matter lesions can lead to things like autoimmune and multiple sclerosis. So, again, if you fire your skill circuits the right way, by trying hard to do things you can barely do in deep practice, then your skill circuits will respond by getting faster and more fluent. So tiny movement fires those circuits. And this is true for the way everything is made in your biology. Simply put, tiny movement sparks biosynthesis. Chiropractic, whether you knew it or not, is at the heart of all this research because of the misunderstood and undervalued mechanism, the proper movement of your spine. Sure, we need more research about this, but simply put, the tiny movement between the adjacent spinal joints, as Nobel Prize winner Roger Sperry put it, the windmill or the power generator to your brain, we know that every living biological thing in your body senses tiny movement. So you can get and stay well for a lifetime. So let's tap into the power of the neural spinal mechanism. Tiny movement, as I like to call it, is explained by those two important sensors in our body. Remember them? The mechanoreception and the proprioception, right? And this is what chiropractic research out of New Zealand just recently discovered. Get this. A study out of New Zealand demonstrated a 20% change in brain function to the prefrontal cortex, as well as improved reaction time. And we know that means increasing myelin, because the increased nerve signal can only be achieved by building and wrapping myelin. Even strength to the muscle, and what 3 weeks of weight training could do with just one chiropractic adjustment. Now let's talk about the mind. During that same study, a behavioral scientist said it would take 6 weeks of behavioral therapy for the mind to get the results that one chiropractic just got on brain scans. Again, more myelin impacts our mind as well. Why not our mood? That was just one adjustment, as we don't have long-term studies as of yet in chiropractic. And now these studies were not done by biopsies, by the way, biopsies on tissues. They were done using brain scans, but with a bit of basic neuroscience, we can conclude that since myelin is the insulator that speeds up reaction times, it must be stimulated after the chiropractic adjustment, speeding up nerve signaling. Again, stimulating myelin is the only scientific way at this time to hypothesize how we get improved reaction times after an adjustment. So bottom line, we have documented research of brain changes and both mood changes and the growth and development of your brain after just one chiropractic adjustment. We also have an older study demonstrating a 200 to 400% increase to the immune system following just one chiropractic adjustment. And we have no long-term studies on this, as I already said, but we can theorize that with time, just as with deep practice and creating neural circuitry and bandwidth, repeated chiropractic adjustments must have the same astounding effects on myelin and skills to create proper nerve signals to every tissue, cell, and organ of the body. So, like a weightlifter building neural circuitry to build muscle, to strengthen tendons and ligaments, basic science can offer an explanation as how repetitive chiropractic adjustments over time can reap significant gains in your health over a lifetime. So like dentistry, chiropractic lifestyle care should be used throughout a lifetime, not for pain management, but for the promotion of your health for a lifetime. Tiny movement, like installing tiny broadband, exercise, and maintaining the proper health and function of your spine, ensures the long misunderstood neural spinal mechanism most responsible for generating the neural circuitry of our brain required to ensure that we stay healthy for life. And the secret is in your myelin. And that's true healthcare. Lighten up, move better, and live fuller.